Important law that we need is the intermediate value theorem. Intermediate means between different values. Let's see how this works. First, if we're given a function that's continuous, this is an important critical part of this theorem, on an interval that includes the endpoints. We also call this closed since it includes both of the endpoints. And k is any number between the y values of the endpoints. K is between the function value at the beginning and the function value at the end. Then we know there exists at least one number c between a and b. C is between the two extreme x values, so that f of c, the y value, is between the y values. This makes sense. If we look at a graph, for example, it's going to be continuous. If we start at the bottom and we want to get to the top and we have to be continuous the whole way through, it's going to take on every y value. Let's take a specific example. Let's take the function f of x equals x squared plus x minus 1. Let's take the closed interval 0 to 5. Notice it includes both the 0 endpoint and the 5 endpoint. And our f of c value is 11. So in other words, in this particular case, k is going to have a value of 11. So let's first verify that the intermediate value theorem applies, and then see if we in fact can find that value of c that we're looking for here. First, the intermediate value theorem applies because we have a polynomial function. Anytime you have a polynomial function, it will in fact be continuous. The original function will be continuous. Now, what we need to do is verify the second part, that k is between f of a and f of b. So if we take f of a is 0, so we take f of 0, we put 0 into our equation, we get negative 1. To take f of b is 5, we take f of 5, so we have 5 squared plus 5 minus 1, which yields 25, plus 5 minus 1, which is 30, minus 1, which is 29. So our two values are f of a is equal to negative 1, f of b equals 29. Now notice 11 is in fact between those two values. So we can now apply the intermediate value theorem. Let's look at the graph for a moment and see what happens here. We have f of 0 equals negative 1 and our f of 5 equals 29. We're trying to find, is there in fact some place at which, if you take the line y equals 11, does this somewhere hit our graph? And it makes sense logically because it's continuous. Y goes from negative 1 up to 29. It doesn't fly. It has to touch every point in the middle. So let's see if we can determine that point. Since f of c equals 11, we would have 11 equals x squared plus x minus 1. So we have 0 equals x squared plus x minus 12. So if we factor, we have x plus 4 and x minus 3. Continuing to solve this quadratic equation, we have the values x equal negative 4 and x equal 3. Notice x equal negative 4 is not in the domain because we're looking from x going from 0 to 5. So in this case, x equal to 3 will in fact give us the place where it hits the line y equal 10. So our graph would look something like this. It's a parabola, but it doesn't look much like a parabola because I've extended the x values out.